so remember these next couple sections are all about how to solve quadratic equations. We have done graphing. We learned that it's not very accurate, but it's a really good visual of what you're doing. Remember, the solutions are at the zeros. Today we're going to do factoring, which we already know how to do. But since this is all about different ways to solve quadratics, we bring it up again to remind ourselves that we do know how to do this already. So, we need to remember that zero product property that says if A times B equals 0, then at least one of them has to be 0. A needs to be 0 or B needs to be 0. Remember, they can both be 0 as well. So that's why we set both parts equal to 0. So we have some that are already factored. We just need to remind ourselves how to use the zero product property. So this first one, I have x plus 2 times x minus 7, and they multiply together to equal 0. So we get x equals negative 2, and x also equals 7. For the next one, sometimes people forget that this guy right here, the x, is one thing. So we need to set x equal to 0, and then also x plus 6 equal to 0. So x equals 0 is one of our solutions, and then the other one is negative 6. And then finally, this very last one, you should get x equals 0 and x equals 5/4. Nothing new there. So we can solve from start to finish with factoring. So remember, this only works if it can be factored. There's some equations that can't be factored, so we obviously can't solve by factoring in that case, but all of these ones that we're going to do in this section can be factored. So remember, it needs to equal 0 so that we can use the zero product property. So A, it does equal 0. Don't have to do any work to do that. But then we want to ask ourselves, what two numbers add to make negative 6 and multiply to make positive 8? So our numbers that do that are going to be negative 4 and negative 2. So we're going to put those two numbers in our factors. And now let's set equal to 0. So zero product property says that we can set both things equal to 0. And we get our two solutions. X can equal 4, or x could be 2. And if we were to graph our equation to check it, we would see that the graph crosses at 4 and again at 2. You can also plug 4 and 2 back into your equation and make sure that it gives you 0. B is a little more work because we need to make one side equal to 0. I'm going to subtract 21 from both sides. That's the easiest to do. So you have x squared plus 4x minus 21, and now it equals 0. So we need to find two numbers that add to make 4, and those same two numbers have to multiply to make negative 21. The only numbers that multiply to make 21 are 7 and 3, and 21 and 1, but 7 and 3 obviously work. And because we wanted to add to make positive 4, the 3 has to be negative. So we can factor this into x plus 7 times x minus 3. And now if we set them both equal to 0, hopefully you guys know we get negative 7 or 3. Very last one, we need to make it equal 0. So what I would do is add 2x squared to both sides, because that's less work than doing it the other way around. So we end up with 0 on the left side equals 2x squared plus 20x plus 50. So before I go any further thinking about what numbers I need, I noticed that the x squared term has a 2 in front of it. So I'm going to check for a GCF, because if there is one, it's going to make my life way easier. And in this case there is, so I'm going to factor out a 2. I'm left with x squared plus 10x plus 25. So now we need to ask ourselves what two numbers add to make 10 and multiply to make 25. And we get 5 and 5. So this can be factored into 2 times x plus 5 times x plus 5. So when we set all of these parts equal to 0, the first one doesn't make any sense. 2 can't ever equal 0, so we can kind of just forget that that even exists. The next one is actually the same as the other one. We'd end up with 2 of these x plus 5s equals 0. We obviously don't need to solve both of them. We know that the only option for x is negative 5. So if we were to graph this, it would look like one of these graphs that only crosses once. So the vertex just touches on that negative 5, and it doesn't cross more than once. And that's it. We already know how to do this, so the video is pretty short. Have a good night.